Welcome to Quantumgrad's video 1 of the math series. In this video, let's cover vectors, their properties, what vector spaces are, and their properties, and finally the Hilbert's rule. So what is a vector then? Well, in math, you might have learned vectors or something like that. In computer science, they're like lists. In physics, they have some directional aspect to them. In quantum physics though, they're denoted in the ket notation where psi is a vector. But essentially, they all pretty much mean the same thing. Now let's discuss some properties of vectors. Alpha times ket u is ket alpha u, where alpha is multiplied to each component of u. This is called scalar multiplication, where alpha is a real number. Another property where ket u plus ket v is ket u plus v, where each elements of u and v are added together. This is also called vector addition, where u and v are vectors. Sounds simple, right? Alright, what is a vector space then? Well, it is exactly what you're guessing it is. It's a bunch of vectors lying around in space, or a collection of vectors. Notice that every vector space must have a zero vector. We'll discuss more about this later in this video. We've talked about earlier that vectors have two main properties, scalar multiplication and vector addition. Both of these are also known as linear properties, and together they form a linear vector space. Some properties of vector spaces include closure property, where vector v plus vector w is vector u belonging to the same space. And another interesting property is commutativity. This is obvious. Ket v plus ket w is the same as ket w plus ket v. The null vector we talked about earlier, well, if you add anything to the null vector, it remains the same thing, so it's an identity property. Now let's discuss inner product. You might know this as dot product. So you take two vectors and do some math on them, and that leads you to a scalar value. So you get a scalar out of two vectors. In Dirac's notation, you have something called a ket and its corresponding bra. So it's also called the bra-ket notation. Kets are vectors, bras are vector transposes. So a bra times its own ket is 1, and a bra times some other ket is a scalar value, just like we saw here. But notice, a ket times a bra is a matrix, not a scalar value. Lastly, let's discuss something called Hilbert space, which is also a vector space with wave functions. A wave function describes the probability of finding a particle in certain space at certain time. In Cartesian planes, we have x, y, z, but in the Hilbert space, you have a set of wave functions. Cartesian planes are 3D, but Hilbert spaces are infinite dimensions. And any wave function can be written as a linear combination of Hilbert space basis vectors. Thank you for watching this video. If you want to learn more math behind quantum computing, check out our part 2 of this series.